Hi, this is Mrs. Basin, and in this screencast we're going to talk about units. So the definition of a unit is the part of the measurement that tells us what scale or standard is being used. So if you just have a number by itself, that number doesn't really mean anything until you add that unit there, and then that tells you what you're comparing it to. So a number by itself, if you're taking some kind of measurement, you always want to have the unit along with the number. The SI units are the units that we use in science. These are based on the metric system and units that are derived from the metric system. So the SI units are important because it's the units that scientists have agreed upon to use when they're communicating information. So when scientists write scientific articles in scientific journals and they share information, they use these SI units so they're communicating with a common language. Metric prefixes can then be used with these units to signify different orders of magnitude. So these are prefixes that you're familiar with from other science classes and math classes before, so things like milli, centi, kilo, those types of things. So here's some other examples. So we talked about the centi and the milli, kilo, mega, giga. Those are usually ones that you see when you're talking about data for transfers over your phone or on a computer. But the ones that we use most often are this kilo, centi, and milli. Micro you use a lot in biology, and then nano and pico, some even smaller ones sometimes we get into in AP chemistry. Okay, so we're going to go through some of the common measurements for some of the different things that we would need to use in this class. So length is our first one. The definition of length is just the distance between 2 points. The SI unit for length is a meter, but in here we'll most likely use the centimeter or the millimeter. We use a metric ruler when we measure length, so you always want to make sure when you're taking a length measurement, you use the metric side of the ruler. And the rulers that we have in the classroom, that would be centimeters or millimeters. We can then use metric conversions to convert from one unit to another. So these are the metric conversions we'll use most often. So 1 meter is 1,000 millimeters. 1 meter is equal to 100 centimeters, and then 1,000 meters is 1 kilometer. Volume is the next measurement we use a lot. And volume is defined as the amount of three-dimensional space occupied by a substance. The SI unit for volume is kind of strange because this is not one that we actually use. We're more accustomed to using liters, but the SI unit, the official SI unit, is the meter cubed. What we usually use in the classroom are milliliters or centimeters cubed. There's lots of different ways to measure volume depending on whether you're measuring a liquid or a solid or an irregular solid. So we can measure volume with a graduated cylinder, a syringe, a burette, a pipette, volumetric flask. If you are measuring the volume of a solid, then you can use a ruler even to measure that. Metric conversions that we'll use most often, 1 liter is 1,000 milliliters. 1 centimeter cubed is 1 milliliter, and a centimeter cubed is a cubic centimeter, which is the same as a cc, and you may have seen that unit cc if you've ever looked closely at a syringe, like when you're getting a shot at the doctor's office. 1 cc is the same as 1 milliliter. So in some cases in class we'll actually use syringes without the needles on them to take volume measurements. Here's a picture of a couple different things. So the graduated cylinder is the one we use most often. Like we just said, the syringe we can use to take cc's. So those marks on a syringe, if it says cc's, are the same as a milliliter. The burette, this third one here, burettes we use in AP chemistry. Those are even more precise way to measure volume. Pipettes can be volumetric or graduated pipettes. We'll actually use these for a lab we're going to do in the next couple days. And then volumetric flasks are calibrated to measure for a certain amount. So a volumetric flask might be to measure 500 milliliters or 250 milliliters, but those are to make a certain amount of a solution. Okay, mass is our next measurement that we'll use a lot. This is how much matter is in an object. The SI unit is the kilogram. In class, we'll most likely use the gram. It's measured with a balance. And then here's our metric conversions for mass. So 1 gram is 1,000 milligrams, 1 gram is 1,000 centigrams, that one we don't use very often, and then 1,000 grams is 1 kilogram. Time is another measurement. Okay, we know time is a period during which an action or process exists or continues. You may not need to write that definition down if you know the definition of time. The SI unit is seconds. amount of a substance, this is kind of a different one. This is probably one you haven't heard of before, and we'll talk more about the amount of a substance later on. But the SI unit for the amount of a substance is a mole. 1 mole is equal to 6.02 times 10 to the 23rd of that substance. So, for example, if you have a mole of apples, you have 6.02 times 10 to the 23rd apples. That is a lot of apples. So we don't use the mole when we're talking about large things. We use the mole when we're talking about much smaller things like atoms and molecules. So we'll come back to this later on. But you can kind of think of this particular term as similar to like a dozen. When you say you have a dozen of something, you know you have 12. Well, when you have a mole of something, you have 6.02 times 10 to the 23rd of that substance. Last unit we need to look at is temperature. So temperature is the energy of motion of the particles. So the temperature is dependent on how much energy the particles in that substance have. The SI unit for temperature is the Kelvin. Now we don't have thermometers that in our classroom anyway that can measure Kelvin. So to get to Kelvin, we have to convert. So we're going to take measurements with our thermometers in Celsius, and then if we need to use the Kelvin temperature, which we'll use a lot more when we talk about gases, we would add 273 to that Celsius measurement. If we're already in Celsius, or if we're in Kelvin and we need to get to Celsius, we would subtract 273. There are 3 temperature scales, and we're only going to focus on 2 of those. The Fahrenheit scale is the one that we're most familiar with, so that's the one that when we look up the temperature and see how hot or cold it is, we use Fahrenheit. The Celsius scale is what they use in most other places in the world, but Celsius is what we'll use in science. So on the Celsius scale, water boils at 100 degrees and it freezes at 0. It's a little bit easier to use because it's like a base of 10, so it goes between 0 and 100. The Kelvin scale, like I said before, we'll use when we talk more about gases. One of the special units on the Kelvin scale is 0 Kelvin. So 0 Kelvin is called absolute zero. What's special about absolute zero is that is the temperature at which all particle motion stops. So even if we have a solid, there's still a little bit of vibration of the particles, but if something gets all the way to 0 Kelvin, which they haven't actually been able to get anything that cold, they've been really, really close, but not that cold, then that particle motion will stop. So this is the lowest attainable temperature. Just a couple of visuals here to kind of help you compare. So we have Fahrenheit. Boiling on Fahrenheit is 212, freezing is 32, we know that. But again, like we said before, Celsius, it goes from 0 to 100. And then Kelvin, 0 degrees Celsius, so freezing point would be 273 Kelvin. So that's a lot different of a scale. That would be kind of a strange temperature scale to use if we were talking about how hot or how cold it was outside. Just to give you kind of a reference point, room temperature in Celsius is usually described as 25 degrees Celsius. So most of the time, if you're in the classroom or if you're in your house, it's usually around maybe 78 or so degrees. That's about 23 to 25 degrees Celsius. That's considered room temperature. This last one is another visual to kind of show you the difference here. Again, Fahrenheit, 0 degrees Fahrenheit is really cold, 100 degrees Fahrenheit is really hot. So we've experienced both of those temperatures over the course of a year. We usually experience both of those. Celsius, 0 degrees is fairly cold. That's just, freezing point. But then 100 degrees Celsius, we wouldn't be able to survive. Kelvin, 0, 100, we would not be around for that. Okay, so just a couple example problems here. Okay, so we're going to see if we can label these in terms of what type of measurement it is. So for this first one, 1.7 milligrams, that is a mass measurement. So mass. 2.06 kilometers, that's length. 0.01 centimeters, and I'm going to abbreviate this, so 0.01 centimeters, that would be a length measurement also. 3.10 cc's, that's going to be a volume measurement. Remember we said cc's is the same as cubic centimeters, which is equal to a milliliter. 40.1 grams, that's a mass measurement. 350 milliliters, that measures volume. 25 degrees Celsius, or 27.5 degrees Celsius, that's temperature. 135 seconds, that would be time. 1.5 moles, that would be the amount of a substance. And then finally 34 kilograms, that would be a mass.